morning, ladies and gents. Mr. Lesham is here, and we're moving on. Okay, we're still in function, but as you can see, we're just touching on kind of general things of all function. We're not focusing on one type of function. We're going to talk about gradient, and specifically average gradient. You'll see why I have to add that word average. And let me start with what you already know. Okay, what kind of function is this? It's a linear. Okay, a linear graph. Right? Normally we write y equal mx plus n. Okay? Maybe your teachers used ax plus b or ax plus q, whatever. But it's always something times x plus something. They have two parameters, and I think we mentioned it somewhere that m is your. What does the m mean? That number in front of x.
The stress.
It's your gradient. Okay? Alright, I'm reminding you stuff from way back. And n, I'm sure we spoke about that, is your y-intercept. Is when x equals 0 is the value of y. That's the y-intercept. Now, the question is, how do I calculate that n? How do I calculate that gradient?
Delta y.
Yes, it's delta y over delta x. The difference in the y, what is delta? It's basically y2 minus y1 divided by x2 minus x1. Always the difference in the y is on top. Don't get confused. Difference of the y on top, difference of the x at the bottom. Specifically for this problem, what would be the delta y?
3 minus 4.
No, okay, so it's the delta y, so the y is in the top. So 3 minus 2 divided by 4 minus 1, which we get 1 over 3. So the gradient is a third.
Isn't there like another way you can do it just by using the points of the
Yes. So if I know, okay, I can try and find, this is basically the delta x and this is the delta y. So if this is basically the same thing. Okay, I'm doing delta y over delta x. Okay? Right. Now let's move on. I'll just pause. So, when we were calculating gradients even in grade 9, we were only looking at linear graphs. What we're going to do now, we're going to calculate gradients of any function. So this is, what kind of function is this? What do we call that? Or this graph, let's say? Parabola. It's a quadratic function, a parabola. And what I'm asking you to do is find, okay, I will say it now. I'm asking, we're going to try and find the average gradient. And let's leave the word average for a second. But the average gradient between x, how do they write it? Calculate the average gradient between x equal 1 and x equal 3. Okay? Now the thing is, we're going to do it exactly in the same way. So let's, for now, just ignore the word average. We're doing exactly the same thing. Okay? So the average gradient, okay, is going to be equal to delta y over delta x. Exactly the same way. Okay? So the first step for me is to find the y's and the x's for each one of them. I've done it for you because I know you can do it. Okay? So let's do it. I changed my mind. Okay? Right. So what do I need to do? Okay? I've got the two x's. What do I need to find out?
Y.
The two y's. Okay? The two y's. Okay? How do I know what the y is? Well, I just use the rule. Okay? So here I use the notation of f of x. So I'm going to use the notation here as well. It's going to be f of x2 minus f of x1 divided by x2 minus x1. It's the same thing as delta y over delta x. I'll put that in brackets. It's the same thing. But what I want you to do is just see this equation, because this equation the textbook uses. This is just the y's. This is the difference in the y. Remember, sometimes I use f of x equal x squared plus 1. Another time I write y equal x squared plus 1. We need to get used to both of these notations. It means the same thing. Okay? So if I use this notation, then I'll write delta y over delta x. If I use that notation, I will do fx2 minus f of x1. Can you see that it's the same thing?
Yep.
Okay? So let's find out, okay, first of all, the x2 and the x1, I know what they are. Okay, that's 3 and that's 1. So it's going to be 3 minus 1, right? So we just need to find out f of x2 and f of x1. When x is, first of all, we start with f of x2. Okay, so I'll put 3 squared. 3 squared plus 1 is?
9.
3 squared.
3 squared plus 1.
10.
10. Okay, so this, I don't know if you saw it, I kind of erased it for you. Okay, so that's 10. Alright? Then I need to know what f of x1, f of 1. Okay, so I'll put 1 squared plus 1 is 2. So 10 minus 2. It's easy. It's easy. Okay? I'll just pause. I can see some questions coming. Okay. What do we get? We get 8 over 2. We get 4. Yippee! The gradient is 4. Now I'm going back to the question. Why did I have to use the word average? Why can't I just say the gradient is 4? It's not a straight line. Well done, Jack. What is gradients? Give me another word to describe gradients. Steepness, the degree of the slope. Okay? Some slopes can be very, what's the word, steep, some not steep. Now I can understand the degree of the slope here, but what about this slope? You know, what do you mean? Do you mean the angle here or the angle there? You can see that the degree, the steepness changes. It changes. Okay? So what we're doing is we're calculating an average gradient just by taking the end point. The end point. Okay? If you want the exact gradient in a specific point, it can be done, and we will learn how to do it next year.
Okay.
Next year, it's a fascinating, the best topic in maths called calculus.
No.
So, it's the best stuff. It's the best stuff. Yes. Yes. Okay, I'm going to pause. Right, so there's no more examples. I think that's all we need to do. So I'll say goodbye, and you guys got to get to work. Bye-bye.